Howdy, folks. What we're going to do in this lesson is we're going to go back to talking about circles, and what we're going to do is we're going to take what we have learned about triangles and vectors, and we're going to put them together with what we learned about circles so that we can understand something that you may already understand, or maybe you know where I'm going with this. If you don't, then just continue along for the ride. It's all going to make sense in a little bit, okay? Well, hopefully it's making sense as we go. At least I hope it does. So here's the deal. Circles, this is a circle, right? And all circles have two important qualities. The first one is they have a center, and the second quality is that they have a radius. And the radius is the distance from the center to all of the other points on the circle. In fact, the center of a circle and the radius of a circle define the circle. All you have to do is tell me where the center of a circle is, tell me what its radius is, and that automatically defines the entire circle, because all the points on the circle are precisely the same distance away from the center. So the distance from here to here is the same as the distance from here to here, same as the distance from here to here. It's an equal distance all the way around the circle from the center. And there are an infinite number of points. Right here, there's a point here, 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 and there are millions of points even in between all those points. So all circles have an infinite number of points on the outside of the circle from the center. But in math, well, in particular in the subject of trigonometry, which is kind of a subset of pre-calculus, we focus on 16 of those infinite number of points. 16 of those points are extremely important to us, probably because they're the easiest ones to determine. Okay, so we have these 16 points that are very easy to determine where they are if we know where the center of the circle is and if we know what the radius of the circle is. And so what I'm going to do is, in the next couple videos, is I'm going to teach you how to identify the coordinates of those 16 points if you knew where the center of the circle was and if you knew what the radius of the circle was, okay? And so in this particular video, I'm going to introduce you to the idea of why do we pick these 16 points. Well, the reason we pick these 16 points, the first thing I need to say is that this circle is, we're going to assume that it's somewhere on the coordinate plane. And so each one of these points actually has an x and a y coordinate. We call that analytic geometry. When we take a geometric shape and put it on a coordinate plane with x and y axes, all the points on the circle now become coordinate points. Therefore, it's like coordinate geometry, and we call that analytic geometry. And the reason for that is because we can turn the geometric shape into an analytic equation. All right? Now, we're not really going to do the analytic equation, but I am going to show you how to identify the points. Okay? Let's talk about this point, this point, this point, and this point relative to the center of the circle. So those 4 points, I call them north, south, east, and west. Okay, you don't have to call them north, south, east, and west, but that's what I call them. Okay, north, south, east, and west. And the idea is those are really easy to identify because whatever the radius of the circle is, east and west are directly horizontal to the center of the circle. Okay, so this one is exactly whatever the radius is. This point is exactly one radius above this point. So if this was the point 7 and 9, then this, we would just add 1 to the x coordinate because we're going 1 to the right. So this would be the point 8 and 9. And then this point over here would be 1 radius less than, oh, I can't say 8 and 9, I'm sorry, that's assuming a radius of 1. Sorry about that. We need to identify the radius first. Really, sorry about that. So let's say that the radius, actually let's say the radius is 5. Okay, so that means the distance from here to this point is 5, right? So we'd have to add 5 to the 7, and this would be the point 12 and 9. So then the distance from this point over to this side would also be a distance of 5, but it's in the negative direction. So we would have to subtract 5 from that 7, and this would be the point 2 and 9. Similarly, this point up here is directly vertical above this point right here, and so, but it's a change in y. The distance from here to here is 5 because that's the radius, but we would add it to the y coordinate because we're going up and down, right? So we're going to go up by 5, so this would be the point 7 and 14. And then down here, we would subtract 5 from the point 9, and we would get the point 7 and 4. And so here, given a particular circle on the coordinate plane and being told what the radius is, you could very easily, and being told what the coordinates of the center of the circle are, you can very easily identify 4 of the main points on a circle. Okay, I'm going to stop here, and I want you, if you downloaded the worksheet or if you have it to work in front of you, why don't you try the first several questions, because the first several questions only ask you to identify those 4, the vertical and horizontal main points from the center. Why don't you try a few of those, and once you understand that, come back to the next video, and I think it'll help you understand a little bit more.